Hello, this is the fifth video of a fifth vector series on lines and planes for OCR Pure Core Further Mathematics. And we will find the perpendicular distance between skew lines. You may be asked to find the shortest distance between two skew lines, where the line equations are r equals a plus lambda c and r equals b plus mu d. You may remember that skew lines do not intersect, nor are they parallel. The shortest distance between them is therefore measured along a line that is perpendicular to both skew lines. Thus we need a different method to the one in the previous video. So we need to find x on line L1 and y on line L2, such that xy is perpendicular to both lines, and therefore also perpendicular to both direction vectors c and d. There is a formula in the OCR formula book for you to use. Let's say the direction that is perpendicular to both lines is n, and a vector joining the two lines is AB. To find the component of a vector AB that is in the direction of n, we use the scalar product. AB, scalar product with the normal n, equals the modulus of AB, modulus of n cos theta. So here we have this normal vector n. We've chosen a point A on L1 and B on L2. And then the vector AB is the line between those. So to find that component of that AB line in the direction of n, we can just rearrange that scalar product. So the magnitude of AB times cos theta equals the scalar product of AB and n divided by the magnitude of n. We can use AB equals the position vector of V minus the position vector of A. And thus we have the formula as given in the formula book. So the distance between the skew lines is given by this formula for D, remembering that B and A are position vectors of points on each line respectively, and that n is a mutual perpendicular to both lines. The modulus on the numerator of D ensures an acute angle theta and a positive distance. Remember that A and B can be any points on L1 and L2 respectively, and that we may need to find the normal first, for example by using the vector product which was introduced in the vector series 3. Just to remind you, the vector product of two vectors, for example direction 1 and direction 2, is another vector. And this vector is perpendicular to both of the vectors that we started with. So for example here, n is perpendicular to both d1 and d2. In this example we're asked to find the shortest distance between the skew lines, remembering that shortest is the same as the perpendicular distance. We know that we can use the vector product to find a vector that is perpendicular to both directions vectors, for example here C and D. And we know that we can use the formula given in the formula book. First of all, then let's find n using the vector product. So taking the direction vector of the first line, vector product with the direction vector of the second line would give us 6 minus 12, 0 minus minus 2, and minus 3 minus 0, or the vector minus 6, 2 minus 3. The length of n is therefore found by taking the square root of those components squared. Which would equal the square root of 49, or 7. So we have found this vector n, and we've also found the magnitude of n. We now need the b minus a. Remembering that a lies on L1 any point and b lies on L2 any point. So let's choose this position vector here to be a, the point A, and therefore that is position vector A, and we'll choose that vector to be position vector B. Therefore b minus a will equal 2 minus 4, 0, minus 1 minus 1, 2, giving us 1 minus 3 minus 2. And we thus have this additional component that we need. Substituting these into the formula for the shortest distance will give us these results. So we already knew that the length of n was 7. And you can see that we've taken the scalar product of b minus a and n, which with that modulus just gives us the 6 over 7. Noting that, as expected, the modulus makes the distance positive. This is the last video of a Vector 5 series.